On this lesson, we're going to focus in on rectangles. You'll be able to identify a rectangle or define a rectangle, identify rectangles also, and find the area. Like we talked about, areas everywhere. You use it in calculus, you use it a lot in this class. Also ties into volume. And you understand what you need to about rectangles if you can apply the properties of rectangles and then also calculate the area. So, could be a lot of properties about rectangles. Some of them are unique to rectangles. We'll get to them in a second. But first, a rectangle is a quadrilateral, so it can only have 4 sides, and it's got to have 4 right angles. 4 right angles. So rectangles have 4 right angles. That's it. That's all you're looking for to see if something is a rectangle. Now, because they've got 4 right angles, a lot of things are going to come from that. So the first thing to notice is that since these are 90-degree angles, 90 degrees plus 90 degrees is 180. So that means that these 2 angles, angle A and angle B, add to 180. Since they add to 180, this is a transversal. Those would be same side interior. Since they're same side interior and they add to 180, that means that the sides are parallel. Same thing on the left and the right. The left side's going to be parallel. You can apply it the same way. 2 lines cut by a transversal, 90 plus 90 is 180. So same side interiors are supplementary, which means they're parallel. So first thing that's going to follow from this is that it's a parallelogram. So everything we learned the other day about parallelograms is true for rectangles. So rectangles are parallelograms. So all of the parallelogram properties are going to be true because rectangles are parallelograms. So remember, for parallelograms, we said opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. The diagonals bisect each other. And consecutive angles are supplementary. All of those things are true. Everything from our last lesson about parallelograms, they're true for rectangles. Now, special for rectangles is that the diagonals are congruent. So, for rectangles, we get all the parallelogram properties and one special one that's just for rectangles, and that's diagonals are congruent. But everything else is true. Opposite sides are parallel, opposite sides congruent, opposite angles are congruent, the diagonals bisect each other, and consecutive angles are supplementary. A couple of those are kind of taken care of by the 90-degree, that all angles are 90 degrees. So for this example, we're going to look and see why this is a rectangle. So first, AD is 3. BC is 3. AB is 4. And CD is 4. Also, AC, the diagonal, is 5. And BD, the other diagonal, is 5. So the first thing that I notice, because I've seen these numbers a lot, 3, 4, and 5. So if you look at where the 5 goes, 5 would be AC. So let me redraw that, just that side. This side's 3, the bottom side's 4, and this is 5. Now, I have a lot of practice with the Pythagorean theorem. So I've seen these numbers a whole lot because 3 squared plus 4 squared equals 5 squared. That's true. It does. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25, which is 5 squared. Since Pythagorean theorem is true, that means that's a right triangle. This angle over here is a right angle. Now, if we drew a different triangle, if we went this way now, it's still got a side of 3 and a side of 4, and then the long side here is 5, which would be the hypotenuse. 3 squared plus 4 squared is 5 squared, so that's also a right angle. And then you can do the same thing with this triangle. Again, we've got the long side is 5, this side's 3, that side's 4. So again, it's the same. 3 squared plus 4 squared equals 5 squared, which means that's a right angle because it's a right triangle. And you can do the same thing down here with that triangle. 3 squared plus 4 squared equals 5 squared, which means that's also a right angle. So it's got to be a rectangle. Now, the other, or another way, not the other way, but another way, is right here. Without using the definition. That's what we just did. We used the definition. All of those angles are right angles because they're all right triangles. But the other thing that we know is our second property right there. Diagonals are congruent. Since the diagonals are congruent, they're both 5, that also means it's a rectangle. So using Pythagorean theorem, just to summarize that one more time, using Pythagorean theorem, we got that all the angles are right angles. Since all 4 angles are right angles, that means it's a rectangle. All 4 angles are right angles. All right, so here's another one. This one we are told it's a rectangle, which means these are all 90 degrees. This whole angle at A is 90. That whole angle at B is 90. We know diagonals are congruent because that's a property of rectangles. But rectangles are also parallelograms, which means the diagonals also bisect each other. So there's tons of stuff going on here. The diagonals are congruent and they bisect each other. They bisect each other, that means these two sides are congruent and these two sides are congruent. But since they are congruent and bisect each other, all 4 pieces are congruent to each other. All 4 pieces would have to be congruent to each other because they bisect each other and they're congruent. The diagonals are congruent. Now we also know that all of these angles total 90 degrees. So now let's look at what we're told. BEC is 26 degrees. BEC. 26 degrees. So we can apply everything we've ever learned in this class. And we're going to figure out all the missing angles. We're just going to label them in the picture. So first thing that you can apply is vertical angles. Since this is 26 degrees, this is 26 degrees. You can also apply linear pairs, because we got a straight line right here, which means straight line's 180, they're going to add to be 180. So since this is 26, this must be 154. And then vertical angles again, so that means right above it, that's also 154 degrees. So we've got all those angles in the middle. That's pretty easy. Now, if you look at these markings we put on here, though, that means that over here, that's a triangle. And it's a triangle with the two congruent sides that are marked right there, which means it's an isosceles triangle. Since it's an isosceles triangle, the two sides are congruent. That also means the two base angles are congruent. That's the isosceles triangle theorem. So those two angles are going to be congruent right there. You could actually apply that about all of these four triangles that get split into. They're all isosceles triangles. So that means these base angles are going to be congruent also. So yet another thing we can apply about triangles from last unit, the three angles in a triangle will always add up to equal 180. So that means x plus 26. Those are your three triangles, the three angles of the triangle, and therefore they add to 180. And if you write it out that way, you get a little algebra equation you can solve. Subtract the 26, find your like terms. X equals 154, so x equals 77. So this angle is 77 degrees. So is that angle. Like we mentioned before, we could take this isosceles triangle here as well. These two angles have to be congruent, so we could say y plus y equals 154, kind of the same thing. Plus 154 equals 180. The three angles add to be 180. Solve it out the exact same way. You get 2y, subtract the 154, you get 26. So y is 13. Now, no matter which way you look at this, this problem needs to make sense. So we said over here, angle C is going to be a right angle. 13 degrees plus 77 degrees is 90 degrees. Every way you look at it needs to make sense. There shouldn't be any flaws, no matter how you look at it. So we can also apply that if you want to finish this off, or we could apply the fact that these two triangles are going to be congruent. We know they're going to be congruent because we've got 154 degree angle in the middle and congruent sides. So that's side angle side, which means everything about this bottom triangle is going to match up perfectly with the top triangle. So that's 13 degrees and that's 13 degrees. We could apply the exact same thing to go across for these 26 degree angle isosceles triangles. Those are congruent also by side angle side. So everything about them is going to be congruent. So if that's 77, this is 77. Same thing over here. It's isosceles, so the base angles need to be congruent. This is a 90-degree angle in the corner, 77 plus 13, 90 degrees. No matter how you look at it, every property should hold up. What's the length of AC to prove ABCD is a rectangle? Given AC is 6x plus 5, that's the entire diagonal, and BD is 8x minus 3, the other diagonal. So the number one property that we wrote about rectangles that's special to rectangles is diagonals are congruent. The only two things we wrote down that are special about rectangles are the definition says you got 4 right angles. Everything about a parallelogram is true for it. But the thing that's unique about rectangles is diagonals are congruent. So AC is one of the diagonals. BD is the other diagonal. They're congruent, which means they're equal. So 6x plus 5 equals 8x minus 3. And then we're going to solve for x. So if you subtract 6x from both sides, you get 2x. And then we'll add 3. Which means x equals 4. Check the question though. What's the length of AC? It didn't just say find x, it said what's the length of AC. So that means you got to plug it back in. Plug in 4 for AC. 6 times 4 plus 5. Six times 4 is 24, plus 5 is 29. AC is 29. So part of the rectangle is drawn here. What's the equation of the line that contains LK? So a couple things that we know about rectangles. That side is going to be the exact same as the side opposite it. So it'll be like over here somewhere. Now, what we don't know necessarily, we can figure it out, is where this is going to be. It could be translated anywhere over here. What does have to happen is that it needs to make a right angle. Angle L needs to be 90 degrees. Angle U needs to be 90 degrees. So if it's going to form a 90-degree angle, it's going to form a 90-degree angle. What do we know about these two lines? If that's a 90-degree angle, they're going to be perpendicular. Perpendicular makes 90-degree angles. So LU needs to be perpendicular to LK. Now, we're talking about slope, obviously, because it talks about slope right here. If you're going to write an equation, you have to know slopes. So we need to know the slope of LU so that we can figure out the slope of LK. So the slope of LU, that's easy. We can count. It comes up 1, 2, 3, 4, over 1, 2, 3. Up 4, over 3. And we also know from Unit 2, perpendicular lines have opposite reciprocal slopes, which means you change the sign and you flip the fraction. So this one's positive, perpendicular is going to be negative. And you flip the fraction from 4 over 3 to instead be 3 over 4. So the slope of LK is going to be negative 3/4. Negative 3/4 means it's going to go down 1, 2, 3 over 1, 2, 3, 4. So our line that we're talking about, LK, is going to look kind of like that line right there. The green dashed line I just drew. Because it has to pass through L and it has to have the negative 3/4 slope. If it's going to pass through L, it has to contain L. That means we have to use this point. So there's our X and Y axis, which means L, the coordinates there are 1, 5. So we know a point, we know the slope, we use point slope form. This is X1 and Y1. That's the point it needs to pass through. And we know the slope, so we're just going to fill everything in. The slope needs to be negative 3/4. X1 is 1. Y1 is 5. You can distribute and make this be slope-intercept form. We don't really need to. So there's your equation.